CH6 Polynomials, Subtopic 6.2, Remainder Theorem. At the end of the lesson, students should be able to relate the remainder theorem to solve problem. So what is a remainder theorem? When a polynomial px divided by x minus a, the remainder is pa. We can write it as pa equals to ra, meaning when we substitute a into the polynomial, we will get the remainder. Previously, to find the remainder, if polynomial px is divided by x minus 2, we will use long division method. First, we're going to put px inside the long division. Next, we put the divisor, which is x minus 2, on the outside. So to get 2x cubed, we will multiply x by 2x squared. So 2x squared times x, we get 2x cubed. 2x squared times negative 2, we get negative 4x squared. So after we multiply, we subtract 2x cubed minus 2x cubed, we will get 0. Minus x squared minus 4x squared, we will get 3x squared. Next, we bring down 3x. Okay, to get 3x squared, we will multiply x by 3x. So 3x times x, we get 3x squared. 3x times negative 2, we get negative 6x. After we multiply, we subtract. So 3x squared minus 3x squared, we will get 0. 3x minus 6x, we get 9x. So bring down positive 1. So we have 9x plus 1. So to get 9x, we will multiply x by 9. So 9 times x, we get 9x. 9 times negative 2, we get negative 18. 9x minus 9x, we get 0. Plus 1 minus 18, we get 19. So 19 is the remainder. We can write it as Rx equals to 19. So what if we use remainder theorem? To find the remainder when px is divided by x minus 2, we're going to use pa equals to ra. So the divisor is x minus 2. So we let x minus 2 equals to 0, x equals to 2. Meaning when we substitute 2 into the polynomial, we will get the remainder. So to get the remainder, substitute 2 into the polynomial. So 2 times 2 cubed minus 2 squared plus 3 times 2. So 2 times 8, we get 16 minus 4 plus 1. If we simplify the equation, we will get 19. So the remainder is 19. This is how we get the remainder if we use the remainder theorem. Example 7 on page 7. Given px equals to x cubed plus px squared plus qx minus 2. When px is divided by x minus 3 and x plus 2, the remainders are 4 and negative 16 respectively. And we have to find the values of p and q. So according to the remainder theorem, when px is divided by x minus a, the remainder is pa. Meaning, when px is divided by x minus 3, so the remainder is 4. And when px is divided by x plus 2, so p negative 2, the remainder is negative 16. So what we have to do, substitute 3 inside the polynomial. So 3 cubed plus p times 3 squared plus q times 3 minus 2 equals to 4. Okay, simplify the equation. So we're going to get 3p plus q equals to negative 7. Q equals to negative 7 minus 3p. So this will be our first equation. Repeat the process with the second equation. Substitute negative 2 inside the polynomial. So negative 2 cubed plus p times negative 2 squared plus q times negative 2 equals to negative 16. Expand and simplify the equation. We're going to get 2p minus q equals to negative 3. So this will be our second equation. So now we have two equations. We're going to do simultaneous equations. Substitute equation 1 into equation 2. Substitute equation 1 into equation 2. So 2p minus q, which is negative 7 minus 3p, which equals to negative 3. So expand 2p plus 7 plus 3p equals to negative 3. 5p equals to 7, bring to the right hand side, we're going to get negative 10. So p equals to negative 2. When p equals to negative 2, substitute into either one of the two equations. So I'm going to substitute negative 2 into equation 1. So q equals to negative 7 minus 3 times p, which is negative 2. So negative 7 plus 6 equals to negative 1. So our final answer is p equals to negative 2 and q equals to negative 1.
Number 8. Find the remainder when polynomial 3x to the power of 4 plus 5x cubed plus x plus 6 is divided by x squared minus 1. So there are two methods of doing this. The first one is by using the long division, and the second one is by using the remainder theorem. I'm going to use the remainder theorem. So the first step, in order to use the remainder theorem, we need to factorize our divisor first. Factorizing x squared minus 1 will give us x minus 1 and x plus 1. Equate equals to 0. So we get x1 and x negative 1. And then we need to assume that our remainder must be in linear function, since our divisor is in terms of quadratic expression. So the remainder must be in terms of linear, so I'm going to assume our remainder is equal to ax plus b. After that, we're going to use the remainder theorem. Remainder theorem states that RA will be equal to PA. And since our first value of x is 1, so we're going to substitute 1 into both of the equation. When we substitute 1 into the remainder, we're going to get a multiply with 1 plus b. And then when we substitute 1 into the polynomial, we're going to get 3, 1 to the power of 4, 5, 1 cubed, plus 1, plus 6. And we're down to the first equation, a plus b equal to 15. That is the first equation. And then for the second equation, we substitute x equal to negative 1 into the remainder as well as into the polynomial. So when we substitute negative 1 into the remainder, we're going to get a multiply with negative 1 plus b. And then when we substitute negative 1 into the polynomial, we're going to get 3 multiply with negative 1 to the power of 4 plus 5 negative 1 cubed minus 1 plus 6. So the second equation is negative a plus b equal to 3. And then we solve both the equations simultaneously. I'm going to get the answer a equal to 6 and b equal to 9. And lastly, we substitute the values of a and b into the remainder, since we assume our remainder is equal to ax plus b. So the actual remainder is 6x plus 9. Example 9, the polynomial ax to the power of 4 plus 2x cubed plus bx plus 3 leaves a remainder of 15x plus 9 when divided by x squared minus x minus 2. Find the values of a and b. So I'm going to write down the polynomial. And the remainder. Since I'm going to use the remainder theorem, so we need to factorize our divisor first. Our divisor is x squared minus x minus 2. Factorizing x squared minus x minus 2 will give us x plus 1, x minus 2. Equate equals to 0. So x negative 1 and x2. Which means we need to substitute both of these values into the remainder and polynomial. So for the first values of x, which is x negative 1, p negative 1 will be equal to r negative 1 or vice versa. When we substitute negative 1 into the polynomial, we are going to get it like this. And then we also need to substitute negative 1 into the remainder. So we get 15 multiplied with negative 1 plus 9. And we're down to the first equation. A minus b equal to negative 7. That is the first equation. And for the second equation, we substitute 2 into the polynomial and also 2 into the remainder, which means we get a 2 to the power of 4 plus 2 to the power of 3 plus b multiplied with 2 plus 3, 15 multiplied with 2 plus 9. So we're going to get the second equation, 8a plus b equal to 10. And then we solve it simultaneously and we get the answer is a equal to 1 over 3 and b equal to 22 over 3.
In page 10, we're going to learn another theorem which is called factor theorem. So x minus a is a factor of the polynomial px if and only if pa equals to 0. Meaning, if we substitute a into the polynomial, we will get a 0 remainder. Previously, if we need to show that 3x minus 1 is a factor of the polynomial px, we have to use long division method. So, to use long division method, we're going to put px inside the long division. So, 6x power 4 plus x cubed minus 25x squared minus 4x plus 4. We divide by the factor, which is 3x minus 1. So, to know what will multiply by 3x to get 6x power 4, so we divide 6x power 4 by 3x. So we're going to get 2x cubed. So put 2x cubed on top. So 2x cubed multiplied by 3x, we're going to get 6x power 4. And 2x cubed, we have to multiply by negative 1. We get minus 2x cubed. So after we multiply, we subtract. So 6x power 4 minus 6x power 4, we get 0. X cubed minus 2x cubed, we're going to get, we're going to get 3x cubed. Bring down negative 25x squared. So to get 3x cubed, so 3x cubed divided by 3x, we know that we have to multiply by x squared. So put x squared on top, x squared multiplied by 3x, we're going to get 3x cubed. X squared multiplied by negative 1, we're going to get negative x squared. So after we multiply, we subtract. 3x cubed minus 3x cubed, we're going to get 0. Minus 25x squared minus x squared, we're going to get negative 24x squared. Bring down negative 4x. So what we'll multiply by 3x to get negative 24x squared? We have to divide negative 24x squared divided by 3x. So we're going to get negative 8x. Put negative 8x on top of the long division. Negative 8x multiplied by 3x, you're going to get negative 24x squared. Negative 8x times negative 1, we're going to get plus 8x. So after we multiply, we subtract. Negative 24x squared minus 24x squared, we're going to get 0. Negative 4x minus 8x, we're going to get minus 12x. Bring down 4. So to get negative 12x divided by 3x, so we're going to get negative 4. So we have to put negative 4 on top of the long division. Negative 4 times 3x, we're going to get negative 12x. Negative 4 times negative 1, we're going to get plus 4. So after we multiply, we subtract. Negative 12x minus 12x, we're going to get 0. Plus 4 minus 4, we're going to get 0. So if you can see here, we have no remainder. So since there is no remainder, we can say that 3x minus 1 is a factor of the polynomial. So 3x minus 1 is a factor of px. That is how we show that 3x minus 1 is a factor of px, by using long division. But since we have learned another theorem, which is factor theorem, we can show that 3x minus 1 is a factor of the polynomial by using the factor theorem. So according to the factor theorem, if x minus a is a factor of the polynomial, if we substitute a into the polynomial, we will get a remainder 0. So since we have 3x minus 1, so let 3x minus 1 equals to 0. So we're going to get x equals to 1 over 3. So if we substitute 1 over 3 into the polynomial and we get 0, then we can say that 3x minus 1 is a factor of the polynomial. So substitute 1 over 3 into the polynomial. So it's 6 times 1 over 3 power 4 plus 1 over 3 power 3 minus 25 times 1 over 3 squared minus 4 times 1 over 3 plus 4. So if we simplify, we should get 0. Then we can say that 3x minus 1 is a factor of px. Shown. Next, we have to know the difference between factor, root, and 0. So factor is written as x minus a, such that if we substitute a into the polynomial, we will get a 0 remainder. And root is written as x equal to a, such that if we substitute a into the polynomial, we get a 0 remainder. And lastly, 0 is written as just a, such that if we substitute a into the polynomial, we will get a 0 remainder. Example 10 on page 11. Given that x plus 1 and x minus 2 are factors of px, for the first part, we have to find the values of a and b. First, let x plus 1 equals to 0, so x equals to negative 1. And let x minus 2 equals to 0, so x equals to 2. Since x plus 1 and x minus 2 are factors of px, according to the factor theorem, when we substitute x equals to -1 and x equals to 2 into the polynomial, we'll get a zero remainder. So this can also be written as p -1 equals to 0. So substitute -1 into the polynomial, we will get 2 times -1 power 4 plus a times -1 power 3 plus b times -1 power 2 minus 2 times -1 equals to 0. This equation can be simplified and we'll get -a plus b equals to -4. Let b as subject, so b equals to a minus 4. This will be our first equation. Next, p2 equals to 0, so substitute 2 into the polynomial. 2 times 2 power 4 plus a times 2 power 3 plus b times 2 power 2 minus 2 times 2 equals to 0. So if we simplify the equation, we will get 2a plus b equals to -7. This will be our second equation. By using simultaneous equation, substitute equation 1 into equation 2. So 2a plus b, which is a minus 4, equals to -7. 2a plus a, we get 3a. -4 transfer to the other side, so we have -7 plus 4, we get -3. So a equals to -1. Next, substitute a equals to -1 into either one equation. So I substitute into equation 1. So b equals to -1 minus 4. We get -5. So the values of a and b are -1 and -5 respectively.
Example 11. Given 1 is a 0 of the polynomial px equal to 2x cubed plus ax squared minus 2x plus b. When px is divided by x minus 2, the remainder is -6. Find the values of a and b. As we all know, since we have two unknown, so we need two different equations in order to find the values of a and b. So for the first part, it is given that 1 is a 0. It means x equal to 1 is one of the root, which means when we substitute 1 into the polynomial, we're going to get the values equal to 0. So we substitute 1 into the polynomial, and then we make it equal to 0. So the first equation that we got is a plus b equal to 0. And then for the second equation, when px is divided by x minus 2, it means that we need to substitute 2 into the polynomial, but then it's not equal to 0. It is equal to -6, since the remainder is equal to -6. So we substitute 2 into the polynomial. And then we make it equal to -6. So we get the second equation, 4a plus b equal to -18. And then we solve simultaneous. And the value of a is 6, -6. And b is equal to 6. So we could write down our polynomial as 2x cubed minus 6x squared minus 2x plus 6. That is for the first part of the equation. The first part of the question. And then for part A, factorize px completely. I'm going to write down the polynomial again. 2x to the power of 3 minus 6x squared minus 2x plus 6. Right. So in order to factorize px, since the highest degree of px is x to the power of 3, so it is safe to say that px have 3 factors, and one of the factor is x minus 1. Since x equal to 1 is one of the roots, so one of the factor is x minus 1. We need to find the other 2 factors. So to find the other 2 factors, we do the long division. X minus 1 is the divisor, and then we do the long division with our polynomial. And then as usual, to do the long division, we need to find what is multiplied with x will give us 2x cubed, or we could just divide 2x cubed with x, which is 2x squared. So we put 2x squared here. So 2x squared multiplied with x, we get 2x cubed, and then 2x squared multiply with 2x squared multiplied with x, we get 2x cubed. 2x squared multiplied with negative 1, we get negative 2x squared. Then we subtract 0. Negative 6x squared minus negative 2x squared will give us negative 4x squared. Bring down negative 2x, and then think again, what multiplied with x will give us negative 4x squared, or we could just divide negative 4x squared with x. It is negative 4x. So negative 4x. So negative 4x multiply with x, negative 4x squared, and negative 4x multiply with negative 1, it is positive 4x. Subtract 0, then negative 6x. Bring down 6, and then what multiply with x will give us negative 6x. We could just divide negative 6x with x, which is negative 6. So we put negative 6 here. Negative 6 multiplied with x, we would have negative 6x. Negative 6 multiplied with negative 1, it is positive 6. Subtract, and we get no remainder. So we could factorize our px with x minus 1, which is one of the factor here, x minus 1, and then the other 2 comes from 2x squared minus 4x minus 6. And then we could just use the calculator to factorize 2x squared minus 4x minus 6. But then before that, we need to simplify. We can move out 2 here. So when we move out 2, we're left with x squared minus 2x minus 3. Then we use the calculator to factorize x squared minus 2x minus 3, which is x minus 3 and x minus 1. So this is how we factorize px completely.